Yeah, the most common mistake on the test was actually these kind of problems, and that's why we're reviewing them first. So some people wanted to start off by like, oh, they see 1 and they'll start subtracting 1 on both sides. But really you want to start off by looking to see if there is the same type of number on the same side first. So like on here you have a 1 minus a 3. You want to change that to a -2 first, bring down everything else, and now we only have a variable and a number on the same side on both sides. Now this is the point where you want to start doing add 2 to both sides, subtract 5 on both sides, that type of thing. So first things first, anytime you have a number on the same side, you have to combine them first. You notice how I didn't subtract 1, I didn't add 3. I just pretended that this wasn't here. I did 1 minus 3 and I got -2. It's on the same side. You don't have to, you know, add it or subtract it like you would if it was from both sides. So number 2, you can see, yeah, it has a number and a variable on the left, a variable and number on the right, so that's done. There's no combining terms. So once you get to this point, you know you're good and you can start. So there's nothing to really do here. There's no combining like terms. What can be combined on number 3? Looking at number 3, what can be combined here? Yeah. So 5, you do the 5 minus 3 first. 5 minus 3 is just 2. And then bring down everything else. -7n equals 14 minus 3n. Just do that one little thing because there's 2 numbers on the same side. Do that first. And you're going to be doing this today on just with inequalities. That's why we're reviewing it. We don't want to do the same mistakes. And usually after this point, 99% of the time, everybody gets it right. And the only other mistake was, I think on the test, was that some people got to something like this, and they said, oh, I messed up because 3 doesn't go into 16. And in reality, the answer was 16 over 3, and -16 over 3, which is fine. That's okay. You don't have to change to a mixed number or decimal. You can leave it just as, yeah, n equals that. So don't worry if you get a fraction. It doesn't mean it's automatically wrong. Okay. Go down to number, let's say, 5. And now this one says do the first and second steps. So we're going to distribute -5 times 2, -5 times 7n, -6 times n, 6 times -4. Do all that first, write it out, and then go ahead and combine the like terms once again. And on the left-hand side, you just bring that down. Okay. Now, if you want, you can do it like I'm doing. You underline the 2 numbers, or if you want, and if you want to like circle the 2 variables or put a box around them to kind of show that they go together. Or actually, this one we could put a box around the whole thing. So variables with variables, numbers with numbers. Alright, I like to do the variables first. So -35 plus 6, and you get, what is that, -29, 10, right? And then do -10 and -24, and you'll get -34. And once again, just bring down the left-hand side. -34 equals. And that's all, because we're just doing the first and second step. We're just making sure you can get to this point where everything on one side is combined, and that's when you start adding 34 to both sides, dividing by 24, and so on. Alright, I'm going to give you a few minutes. Go ahead and finish up 1 through 8 for sure. I'll be walking around checking those. And then go ahead and do the review for just graphing. If you need to on the board, look at the symbols, which way, you know, does the arrow point, and that kind of thing. Is it open or closed? We want to make sure we got those details taken care of. And the next part is looking at the graph, can you write the inequalities? So 9 through 12 and 13 through 16 are counterparts. Same question, just this time you get the graph, given the inequality. This time you're given the graph, you have to write the inequality. So let's take a few minutes on that and try to get up to at least number 16. And I'll be around checking. Okay. Do we need to go over anything up through 16? Any questions we need to clarify? Number one thing, of course, number one mistake is always negative, so if there is a mistake, try to check those first. Next, let's look at number 17 and 18. So, just wanted to review, how do you know if it's a special answer or not? Okay, so special case means variables cancel out. Cancel out on both sides. Variables cancel on both sides. So, for instance here, we'll get negative 8 plus 8 equals 11 minus 8x. And when you go to solve, you get variables canceling out or equaling 0 on both sides. And you're left with 8 equals 11. And on number 18, we'll have negative 6n there. And when you go to solve this, you see, once again, variables cancel out on both sides. You're left with 1 right here, and you're left with 1 on the right-hand side. So what was the convention we used to know if it's a all real or a no solution? So this is very important. Do not say if the number is the same, then it's all reals. If the number is different, then it's no solution. Do not use that. Okay? Use this. If it's a false statement, then it's no solution. Meaning 8 does not equal 11. It's false. And over here, 1 does equal 1. So that's true. And that means all real. This is what you want to use, and I'll show you why right now. On the back, you're going to have these in inequalities. Alright? So watch this. What happens if I change this equal sign right here to a less than or equal to sign? What would the answer be then? It would be 8 is less than 11. Is this true or false? So the answer is all reals. It's a true statement. You see how these are different numbers? So if you're saying, oh, different numbers, no solution, that would be incorrect because, well, that doesn't really work. You have to say, well, is 8 equal to 11? No, it's false. Is 8 less than 11? That's true. It's all real numbers. Likewise, if over here on number 18, what if I made this greater than? What would the answer be then? 1 is 1 greater than 1? No, that would be false. No solution. So the numbers are the same, but it's a false statement. Therefore, it's no solution. So if you're using the convention, if the numbers are the same, then it's always no solution. If the numbers are different, if the numbers are the same, it's all reals. If the numbers are different, it's no solution. That will not work. So you want to switch to using, is it true or is it false, what you have. Okay? Very important distinction between equations and inequalities. And you'll come across that on the back side. Okay? Oh, by the way, make sure you always actually label this. There were a few people on the test that had this, but they didn't actually write out no solutions. And then or they didn't write out all real numbers. You want to actually write that out in words, in full, when that's the case. Don't just stop and say 1 equals 1 and that's it. You got to finish it up with writing all real numbers. Alright, so let's look at the back. I want to go over one last thing, and you guys can work the rest of the period. let's go ahead and start 19 together. So what does negative 2x and negative 4x make? Negative 6x. Right? You're going to divide both sides by negative 6. Now, you might remember this from when you learned inequalities for the first time. When you divide by a negative, you must switch the inequality sign. And we'll go into a whole reason for this later. But yeah, when you divide by a negative, you must switch that inequality sign. So the greater than or equal to became less than or equal to. And when you graph, it's going to change the direction of your graph. So we're going to start at negative 2. Is this going to be open or closed? Closed graph. And it's going to go to the left. So dividing by a negative or multiplying by a negative, you switch the sign of the inequality. Switch the inequality sign. Very important detail. Okay. And if you want to, you can always write that out in words. Switch the sign when multiplying or dividing by a negative. This is the biggest difference between inequalities and equations. Equations, you don't have to worry about this, but inequalities you do. Dividing by a negative and switching the sign. So a less than becomes, a greater than becomes a less than equal to, and vice versa. And then a greater than becomes a less than, and vice versa. A less than becomes a greater than. Alright, so when you're checking your answers, if your answers come out very similar, but one of you is pointing one way, the other is pointing the other way, check to see if you divided by a negative or multiplied by a negative, and that could be why you have a different sign, but the same number. So, small but important detail. Okay, I'll let you work for the rest of the period, which is about 7-8 minutes. Okay. And again, I'll be checking all these tomorrow, so please come in with everything finished. Look at everything on the back, look at the hardest problem, and go ahead and do that first. So you leave here with the hardest problem done, and you can finish the easier ones later.